Yes, good afternoon, class. We have started with the state feedback controller design, and we were at the numerical of designing that. Mm, So, starting with the numerical, yes, obtain the state variable feedback. I am again repeating that same numerical. Obtain the state variable जाण्याचं मग असं ते कुठे जायचं हा ओपन झाला आहे ना क्लिक करा ना त्याच्यावर obtain the state variable feedback u equals to kx so that the closed loop system exhibits an underdamped response response with zeta equals to zeta means damping ratio. You know that we have seen in time response analysis in control system 1. Zeta is your time damping ratio, and what is this TS? That is settling time, and TS equals to 4 seconds. Take the smallest time constant. Take the smallest time constant of a system as 0.1, smallest time second, and the state equation they have given x dot equals to A matrix they have given. A matrix 0 1 0, then 302 302, then minus 12 minus 7, and then 6 into x plus B matrix they have given. What is this B matrix? It is 111 matrix. 111 into U. And what is this C matrix they have given? It is a row matrix 111 into U. So this is your A matrix, this is your B matrix, this is your C matrix. Okay, now starting with the solution part, you know that how we are approaching to all the numerical solution is that we are starting with the characteristic equation. So the characteristic equation is given by mod of lambda I minus a equals to 0. This is the condition to solve the characteristic equation and to get the eigenvalues for. So lambda I minus a. Now I am writing here lambda I matrix. Lambda I means identity matrix. So lambda 0 0 0 lambda 0 0 0 lambda. This is your lambda I minus A matrix. A matrix is nothing but given matrix 0 1 0 3 0 2 minus 12 minus 6. This is your lambda I minus A equals to 0. So I have to simplify this. So what will be the simplification? Lambda minus 0, it would be here lambda minus and 0, and again second row it would be minus 3 lambda minus 2, and the last row it would be minus 12 7 lambda minus 6. So I have to solve this to get the eigenvalues. Yes, have you understood up to here? Now moving forward. So solving this characteristic equation, that is lambda minus 6 lambda square plus 11 lambda plus 42 equals to 0. So this is the characteristic equation. To find the roots for this equation, that will be your eigenvalues. Okay. So as there is lambda 3, there would be a 3 eigenvalues. So please take out your calculus and solve this quadratic equation to get the eigenvalues. So the eigenvalues are comparing with the standard equation. Now comparing with the standard equation, comparing with the standard equation, here a1 equals to minus 6. Okay. Second term, that is a2 equals to 11, and then a3 equals to 42. I have compared this equation. So the lambda square value, it is 6 minus 6. That's why I am written a1 is minus 6, and a2 would be here 11. That is lambda coefficient, and the constant term, that is 42. So a3 is 42 here. Okay. So for underdamped system, for underdamped system, the roots would be roots of the equation. So how to find the roots for this underdamped system? Yes, you know the formula, S equals to minus zeta omega n plus minus j omega n under root 1 minus zeta square. This formula you have to keep in mind to find the roots for the equation. That is S equals to minus zeta omega n plus minus j omega n under root 1 minus zeta square. So what given values are there? So you are given with T equals to, it is equal to handling time for zeta omega. This is the formula for zeta m. So I can easily find out. Uh, they have 4. So 4 equals to zeta omega m. And value it would be omega n value I have to find. Omega n equals to 4 divided by 0.8 into 4, that is 1.25. Okay. Now the desired closed loop poles would be desired closed loop poles. Yes. Yes. the desired closed loop poles, it would be S equals to minus, yes, put that value, zeta omega n 0.8 into 1.25. Okay. So the desired closed loop poles. Yes. Am I audible clearly? The desired closed loop poles. How to find the desired closed loop pole? Yes, formula is equals to minus zeta omega n under root 1 plus zeta square. So 0.8 into 1.25 plus j 1.25 under root 1 minus zeta square. 1 minus what is the value of zeta? 0.8 whole square. Okay. So you have to find out the roots for this. So S equals to what are the roots? Minus 1 plus minus j 0.75. 0.75. So one root it would be minus 1 plus j 0.75 and the second root it would be minus 1 minus j 0.75. Since the eigenvalues and poles are similar and the poles are similar terms. So what were my eigenvalues? Yes, lambda 1 equals to minus 1 plus j 0.75 and then lambda 2 it would be minus. Okay, here sign minus 1 minus j 0.75. These are the two eigenvalues. How to find out the third eigenvalues? As my quadratic equation was lambda cube, this was my two eigenvalues, lambda 1 and lambda 2. How to find lambda 3? See the formula here. Lambda 3 equals to minus 1 divided by time constant. Time constant. So minus 1 divided by what is the time constant they have given in numerical? 0.1. So minus 1 divided by 0.1 means minus 10. So lambda 3 value it would be minus 10. So putting all these values together in one term, so lambda plus 1 plus j 0.75, this is your first eigenvalue. Second eigenvalue would be lambda plus 1 minus j 0.75 and the third eigenvalue was lambda plus 10. Here, this is your third eigenvalues, this was your first, this is your second and then third. So multiplying all these uh, eigenvalues together, that would be equating to 0. So multiply all these eigenvalues together. Lambda cube plus 12 lambda square plus 21.56, 21.56 lambda plus 15.62. You have to make simplification for this. Okay, this you have to simplify. Multiply all these bracket. It would, as there are 3 lambda, it would be lambda cube. So you have to simplify. Now comparing this equation with the standard, comparing the equation with standard. Okay. So as we have already calculated a1, a2 and a3, now I will be calculating lambda 1, lambda 2 and then lambda 3 or analog notation. Alpha 1 equals to 12 here comparing and then alpha 2 equals to 21.56. Yes, alpha 1, alpha 2 and then alpha 3 would be 15.62. So as I am having a1 alpha 1, and all, I can easily find out the Kc value. Kc value can be easily found out. Okay. So what is this Kc value? Kc matrix. Kc matrix is nothing but alpha 3 minus A3 first bracket. Okay. Next bracket alpha 2 minus A2, and then third bracket alpha 1 minus A1. This is your Kc matrix, row matrix. So what is my alpha 3? Just calculate it. 15.62. 15.62 minus A3, it is 42. Okay, first bracket. What is alpha 2? 21.56. 21.56 minus what is A2? A2 is nothing but 11. What is alpha 1? 12 minus 6 means 12 plus 6. This is your Kc matrix. So Kc it would be coming 15.62 input means minus 20.48. And then 21.5 minus 11 means 10.56, and last 12 plus 6 means 18. So this is your Kc matrix. Okay. So as usual, QC, that is controllable matrix. How to find out controllability according to Gil? B A B B A square B. Okay. So to check the controllability, that QC matrix is should not be equal to 0. Then I can say that my system is completely controllable. So I have to find that trick here. This is my B matrix. Yes, I have given already. B A B. Okay. B matrix is 1 1 1. What is my AB matrix? AB means multiplication of A and then B. That is 0 1 0 3 0 2 minus 12 minus 7 6. This is A and B matrix 1 1 1. AB. Yes, what will be the answer here? AB, and then I will be finding A square B. So A square B means you will be taking 2 times 0 1 0 3 0 2 minus 12 minus 7 6. This is your A. Again you have to write this A because it is A square. 0 1 0 3 0 2 minus 12 7 6. This is A square, and then it will be multiplied with B. 1 1 1. A square B. So we have to find out these two matrices, B and then AB. Okay? Yes. Now moving forward, what is the next step? You have to take the inverse for this matrix. Inverse, that is QC inverse. Inverse for matrix. So QC inverse, it is coming as 1.013 minus 0.065 minus 0.052. Okay. Here second row minus 0.11 minus here it would be 0.142 minus 0.03, and last row it would be 0.02 0.02 minus 0.004. I have to find the P matrix. P1 equals to, yes, I have told you yesterday, P1 you have to always take 0 0 1 matrix. So this is P1 matrix. Now P1 into QC inverse. Okay. So P1 into QC inverse, that is 0, 0, 1 into this QC inverse matrix. So what it will be coming? It would be coming as 0 0.02, 0 0.02, and then minus 0 0.04, minus 0.004. This is your P1 matrix. Okay, so you know that how to find P matrix, complete P. This is P1, this is P1A, and third row it would be P1 into A square. Okay, so you have to find out these all values for this, and what it is coming as 0 0.02, 0 0.02, 0 0.02, 0 0.02, okay, 0 0.108, 0 0.048, and then 0.1016, and last row minus 0.048, minus 0.004, here 0.192. This is your P matrix. Now moving forward. Now finally what I have to find, now finally K equals to Kc into P matrix. So Kc, you know that. Kc matrix we have already find out. Minus 26.48, 10.56, 18. Okay. And your P matrix multiply your P matrix. So K matrix it would be finally K, that is controllable matrix, 1.476, 0.264, and then we are finding K matrix or the feedback controller, what you have to find for the system. Okay. ठीक है, फिर आज के लिए एक ही न्यूमेरिकल काफी है. तो इसमें क्या पढ़े अपन ने, हाउ टू डिजाइन द स्टेट वेरिएबल फीडबैक फॉर एनी गिवन सिस्टम और द गिवन सिचुएशन. You have to design the feedback controller. So you have to keep the steps in mind how to find out the feedback controller. First of all, you have to take the characteristic equation, and you have comparing with the standard equation. Standard equation is lambda cube plus a1 lambda square plus a2 lambda plus a2 lambda plus 3. Okay. खराब झाले होते ना की माझं साऊंड सिस्टम. ठीक है, फिर अटेंडेंस मार्क कर लो, चैट बॉक्स में अटेंडेंस दी है.